Alright everybody, what's up? In this video we're going to learn how to integrate using trigonometric substitution. So the first thing that we've got to do is we've got to know this table here. So if we have an expression of square root of a squared minus x squared, we're going to use the substitution x equals a sine theta, where theta is between negative pi over 2 and pi over 2. And if we have the square root of a squared plus x squared, we're going to use the substitution x equals a tangent theta, where theta is between negative pi over 2 and pi over 2. And notice up here the negative pi over 2 and pi over 2 is included, but down here it's not. Tangent's undefined at negative pi over 2 and pi over 2. And then we have, if we have the square root of x squared minus a squared, then we'll use the substitution x equals a secant theta, where theta is between 0 and pi over 2. Okay, now notice the 0 is included, but the pi over 2 isn't. And here the pi over 2 is included, but the 3 pi over 2 is not. And that's because at pi over 2 and 3 pi over 2, secant is undefined. All right, so let's go ahead and start working some examples. So for this one, we got square root of 9 minus x squared over x squared. Now you can see we're in the form a minus x squared. So you can see, or not a, but a squared minus x squared. So you can see a squared minus x squared. So we're going to use x equals a sine theta. And now remember, this is a squared. So 9 is a squared. So we know a is equal to 3, because 3 squared is 9. So we're going to let x equal 3 sine theta. All right, and now we're going to put 3 sine theta in for x here and here, but we also need to know what dx is. Well, dx, the derivative of this, that is what? That's 3 cosine theta d theta. So this is going to give us the the integral of the square root of 9 minus 3 sine theta squared over 3 sine theta squared. So all I did is I replaced the x's with 3 sine theta times dx. Well, what's dx? dx is 3 cosine theta d theta. So times 3 cosine theta d theta. All right. So probably what I'll do on this problem, on this part of simplifying, I'll show all the steps in all my work on this problem, and then on the rest of the problems I'll kind of leave some stuff out, but it's the same process, okay, as all these steps I'm fixing to show. So this is the integral square root 9 minus 9 sine squared theta, okay, over 9 sine squared theta times 3 cosine theta d theta. So all I did is I squared this and I squared this. All right. And so now we have the integral square root, and I'm going to factor out a 9. And that's 9 sine squared theta times 3 cosine theta d theta. Okay, so I just factored the 9 out, and look at this. You see 1 minus sine squared? Well, what is 1 minus sine squared? Let's just go ahead and keep going like this. So 1 minus sine squared, that's cosine squared, right? Because sine squared plus cosine squared is 1. And all I did, I just solved for cosine squared, and that's 1 minus sine squared. And that's over 9 sine squared theta times 3 cosine theta d theta. And now if I take the square root of this, that's going to be the integral 3 cosine theta absolute value, and I'll explain that in a minute. All right. So what's the deal with absolute value? Well, remember, and I'm going to explain it in detail on this problem, and then the rest of the problems are similar to this. Okay. So why absolute value? Well, remember, when you take the square root of something, you get a positive answer, right? Like the square root of 9 is positive 3. The square root of 16 is positive 4. All right. So we have to put this in absolute value. We got to put it in absolute value to show that we're taking the positive answer. Well, we can rewrite this as the integral. Now look, let's go ahead and cancel out the 3's, because 3 times 3 is 9, and that's going to cancel with that 9. So this is cosine theta. So the absolute value of cosine theta, I'm writing that as cosine theta times cosine theta, this cosine theta, over sine squared theta d theta. All right, now how was I able to write cosine theta here? Okay, how was I able just to drop the absolute value and just write cosine theta? Well, remember, if you have the absolute value of x, that is equal to x if x is greater than or equal to 0, and negative x if x is less than 0. All right. Now, I'm not going to explain it in detail on the rest of the problems. I'm just doing it on this one problem, and all the other problems are the same. Okay. So remember, if this inside the absolute value, if it's positive, then it's just what's inside the absolute value. But if what's in the absolute value is less than 0, if it's negative, then it's the negative of that. So how do I know I can use the positive? Well, let me show you real quick. It all goes back to this up here. This right here, this is the substitution I used. Theta is between negative pi over 2 and pi over 2, right? So that means I'm in the first and fourth quadrant, and we know that cosine is positive in those two quadrants. And so that's how I know this cosine is positive, so I can just write positive cosine. And so now I get cosine squared theta over sine squared theta d theta. And that's equal to the integral, and that's going to be cotangent squared theta d theta. All right, so I don't know what the antiderivative is of cotangent squared, but I can use an identity. Cotangent squared is cosecant squared minus 1 d theta. Because remember, 1 plus cotangent squared is cosecant squared. And then if I solve, I get cotangent squared is cosecant squared minus 1. Well, now I know the antiderivative of cosecant squared. That's what? That's negative cotangent theta minus, and then the antiderivative of 1 is just theta. And then don't forget your plus c. All right. Now, we integrated it, but we're not finished because our answer needs to be in terms of x. Well, let's go back up here to the fact that I chose x. Remember, I chose x to be 3 sine theta. So this tells me sine theta is equal to x over 3. And so if I draw my triangle, okay, and I call this theta, remember sine is opposite over hypotenuse. And by the Pythagorean Theorem, this is 9 minus x squared. And I'll show it one time on this one. Say we were looking for this side. We'll just call this side y. So I know x squared plus y squared is equal to 3 squared. And so that gives me y squared is equal to 9 minus x squared. So y is equal to the square root of 9 minus x squared. All right. So that's where that 9 minus x squared came from. All right. So now what do we need to know? We need to know what cotangent theta is. See the cotangent theta? Well, what's cotangent theta? Well, we know tangent theta is opposite over adjacent, right? Opposite over adjacent. Cotangent is the reciprocal of tangent. So cotangent is adjacent over opposite. So that is square root of 9 minus x squared over x. You see that? And then what do I need? So I've got this. Now I need to know what theta is. Well, I've got sine theta is x over 3. So this tells me theta is the inverse sine of x over 3. And so my final solution is negative square root of 9 minus x squared over x minus inverse sine of x over 3 plus c. And there's my answer. All right. So I hope all that made sense. I went into detail with this problem, but in future problems, like for instance, doing this and then getting to here, I'll probably just say, okay, we're going to factor out a 9. That leaves us with 9 times 1 minus sine squared. 1 minus sine squared is cosine squared. So in future problems, I'll probably go from this step to this step, and I'll leave this out. Okay? All right. All right, so let's look at this. Find the area enclosed by the ellipse x squared over a squared plus y squared over b squared equals 1. All right, so let's just make a quick sketch of this. And I know that's not a very good ellipse. But remember, from graphing an ellipse, this is a0, this is negative a0, this is 0b, and this is 0 negative b. All right, so I need to get a function. So what I'm going to do is I'm going to take this and I'm going to solve it for y. Okay, so I get y squared over b squared is equal to 1 minus x squared over a squared. All right, which this is y squared over b squared is equal to a squared minus x squared over a squared. I just got a common denominator of a squared. And so if that's a squared, then the numerator is going to be a squared. So a squared minus x squared over the common denominator, a squared. And so this is going to give me y, okay? This is going to give me y squared is equal to b squared times a squared minus x squared over a squared, which is equal to, I'm sorry, not equal to, this is going to give me y is equal to plus or minus b over a times the square root of a squared minus x squared. So where did that come from? Well, I took the square root of this, right? So the square root of b squared is b, the square root of a squared is a, and then this just has to stay under the square root, all right? And this is also the function I'm going to use to find for my integral. All right, so I'm going to use y equals b over a times the square root of a squared minus x squared, and also x is between 0 and a. So let me explain this. So you might be wondering, well, why are you only using the plus and not the minus? Okay, so I'm using the top half, okay, and x, and I'm doing the x is between 0 and a. Okay, it's in between here. Now, let's talk about this for just a second. Okay. So to find the area, to find the area enclosed by this ellipse, I'm going to just find that. And when I find this area, I can multiply it by 4, and that'll give me the area inside the entire ellipse, because all of these regions are symmetrical. All right, so my area is going to be the integral from 0, from 0 right here to a of b over a times the square root of a squared minus x squared dx, and I have to multiply that times 4, because this area right here, just the integral, that gives me this area right here, just this area in the first quadrant, and then multiplying it by 4 gives me the entire area. All right, so what substitution do I make? What substitution do I make? Well, I've got a squared minus x squared. That's this one up here. Okay, so what you might want to do, if you haven't already, pause the video and just write this and this down. Just write each of those down. So, because I'm not going to keep coming back up to it. Okay, so I'm going to make the substitution that x is equal to a sine theta. All right. All right, so I've got x is equal to, see, there's a squared, so that's a sine theta. And so dx is a cosine theta d theta. And so I get 4 times the integral 0 to a. Now, the b, let's go ahead and do this also, just to kind of make it a little easier. Let's go ahead and pull out this b over a. That's just a constant term. And let's make our substitution. A squared minus a cosine theta squared d theta. Whoop. All right. Times what? times a cosine theta d theta. All right, so, I'm sorry, that should be sine theta. All right, I don't know, for some reason I put in a cosine theta instead of a sine theta. It's x is a sine theta. Dx, in the place of dx, I put a cosine theta d theta. All right, so now we have 4b over a times the integral 0 to a, and that is going to be, I'm sorry, okay, so my bad here. Okay, so, and I'm kind of glad I left it out, or didn't do it right, so I can point it out now. So, and I just realized it when I wrote this step down. So, see, we're in terms of x, and now what we're doing is we're changing our problem to be in terms of theta. So that means I have to change my limits. See, my limits are in terms of x up here, but now I need my limits in terms of theta. So how do we do that? Well, here we got x is equal to a. So if I plug a in for x, that's going to give me a equals a sine theta. And so that's going to give me sine theta is equal to 1. Divide both sides by a. So that's going to give me theta. Well, when is sine theta 1? That's going to be what? At pi over 2. And so this should be pi over 2. And then I have to plug the 0 in for x. So 0 equals a sine theta. Divide both sides by a. That's sine theta equals 0. Well, that means theta is equal to 0. And so that would be 0. So 0 to pi over 2. All right. So now I've got a squared minus, and then when I square this, that's a squared sine squared times a cosine theta d theta. All right, so this is going to give us 4b over a times the integral 0 to pi over 2. Now, I'm going to factor out of a squared, so I've got a squared times 1 minus sine squared. 1 minus sine squared is cosine squared. So that's the square root of a squared cosine squared. Okay, that's what I showed all that work in the first problem. Times a cosine theta d theta. All right, so now we've got the square root of this is a cosine theta. So I've got a cosine theta times a cosine theta. And yes, it's the absolute value of cosine, but we know we're in the between negative pi over 2 and pi over 2. So I can drop the absolute value and just put cosine theta, just like in that first problem. All right. So that's going to be 4b over a from 0 to pi over 2. And a cosine theta times a cosine theta is a squared cosine squared theta d theta. That looks like a 9, but it's an a. And so when I bring the a squared out, that's going to be 4ab. A squared and a cancel. I'm left with the a. So that's the 4ab from 0 to pi over 2 cosine squared theta d theta. All right, so hopefully you still remember this. So remember when you did trigonometric integrals, okay? I just did a video on that. I did a video on that right before this one, so check out that video, trigonometric integrals. We work a problem similar to this. So this is going to be 4ab from 0 to pi over 2. Now, to integrate cosine squared, remember, what do? You have to use one of those half angle identities. And that's going to be 1/2 times 1 plus cosine 2 theta d theta. And so this is going to give me 2ab. I'm going to bring out the 1/2. 4 times 1/2 is 2. That's where that 2 comes from. 0 to pi over 2 of 1 plus cosine 2 theta d theta. All right, so now we're ready to integrate 2ab times the antiderivative of 1 is theta plus, now let's integrate cosine 2 theta. All right. So what's the antiderivative of cosine? That's sine, right? But it's going to be 1/2 sine 2 theta. And that is going to be evaluated from 0 to pi over 2. All right, so how did I do that? Well, let's just real quick on the side, and I'm going to do this fast. So remember, cosine 2 theta, you can use substitution if you want. U equals 2 theta, so du is 2 d theta. All right, so I need it. See, I only have a d theta, so I need a 2. So I multiply by 2, come out here and multiply by 1/2. And so that's 1/2 cosine u du. So that's 1/2 sine u. And so that's 1/2 sine, and then in the place of u, we're going to put 2 theta. Okay, so in case we run into this later on, just remember this. This is how you could do it. Or you could just know that it's the antiderivative of cosine is sine, and then it's times the reciprocal of that number in front of theta. All right. All right, so now we're ready to evaluate. So this is going to be 2ab times, that's going to be pi over 2 plus 1/2 sine of 2 times pi over 2 minus 0 plus 1/2 sine of 2 times 0. All right, so we've got the sine of pi right here. Well, what's the sine of pi? It's 0. This is 0, and the sine of 0 is 0. And so we're left with 2ab times pi over 2. And the 2's cancel, so we get pi ab, or ab pi. However you want to write it, it doesn't matter, but this is your answer. All right, let's look at the next one. Yeah, I have a feeling this is going to be a pretty long video. All right, so we've got x squared plus 4, the square root of x squared plus 4. So if you look at that table, we're going to let x equal a tangent theta. All right, and in this case, a is 2. 2 squared is 4. All right, so I've got x is equal to 2 tangent theta. Dx is 2 secant squared theta d theta. So let's plug everything in. So that's going to give me the integral 1 over. Now in the place of x, we're putting 2 tangent theta. So that's 2 tangent theta squared times the square root of 2 tangent theta squared plus 4. All right. Times dx. Well, what is dx? Dx is 2 secant squared theta d theta. All right. So this is going to be the integral of 1 over, and I'll tell you what I'm going to do. I'm going to go ahead and write 2 secant squared theta. I'm just going to write the 2 secant squared up here in the numerator. So that's 4 tangent squared theta times the square root of 4 tangent squared theta plus 4. All right. So now we've got what? The integral of 2 secant squared theta over 4 tangent squared theta. Now let's look at this. I'm going to factor out a 4. So that's going to leave me 4 times tangent squared plus 1. Okay? And what is tangent squared plus 1? That is secant squared. Okay? Remember your identity. Tangent squared plus 1 is secant squared. And then I've got d theta. All right, so this is going to give us what? This is going to give us the integral 2 secant squared theta over 4 tangent squared theta times 2 secant squared theta d theta. And you can see the 2's, I'm sorry, not secant squared, just secant. Square root of secant squared is secant. And once again, yes, absolute value of secant theta, and then secant theta is positive because of what theta's in between. Just go look back up at the chart and you can see secant theta would be positive. So that's why we can just put secant theta. And so this is equal to 1/4 times the integral. The 2's cancel. I'm going to bring the 1/4 out. And that's going to be secant theta over tangent squared theta d theta. All right, so how do I go about integrating this thing? Well, I think it's going to be best to go ahead and rewrite everything in terms of sine and cosine. Okay, secant theta is 1 over cosine, tangent squared is sine squared over cosine squared. And so this is 1/4 integral of 1 over cosine theta times cosine squared theta over sine squared theta d theta. And you can see cosines cancel. I'm left with 1 cosine up here. So that's 1/4 times the integral cosine theta over sine squared theta d theta. And so remember, this is sine theta in parentheses squared. So this is U-Substitution. So I'm going to let U equal sine theta. du is cosine theta d theta. And so I've got 1/4 integral. In the place of cosine d theta, I'm going to put du. And in the place of sine, I'm going to put u. So that's u squared. And so that's 1/4 integral u to the -2 du. And so that's 1/4 u to the -1 multiplied by the reciprocal of your new exponent plus c. And so this is going to give me what? this is going to give me negative 1 over 4u plus c. All right. So this is going to be negative 1/4. Well, let's see, how do we want to do this? Negative 1 over 4, and then what's u? That's sine theta plus c, which this is equal to negative 1/4, and 1 over sine is cosecant. Now, let's draw our triangle. All right, so what was my substitution? X equals 2 tangent theta. So I had x equals 2 tangent theta. So that means tangent theta is equal to x over 2. If I call this theta, remember tangent is opposite over adjacent. So by Pythagorean Theorem, this side is x squared plus 4. All right. Now I need to know cosecant theta, because remember I got to get everything back in terms of x. So that's negative 1/4, and then we have cosecant theta. Well, cosecant is the reciprocal of sine. We know sine is opposite over hypotenuse, and cosecant is the reciprocal of that. So cosecant is hypotenuse over opposite. So that's square root of x squared plus 4 over x. And so times cosecant theta, that's square root of x squared plus 4 over x. And so that's going to give us negative square root x squared plus 4 over 4x. Whoop, and I left off my plus c, didn't I? Plus c. Don't want to forget that plus c. All right. All right, so moving right along to the next problem. We got the integral of x over x squared plus 4. All right, so we got the x squared plus 4. So what is our substitution going to be? Okay. Oh, wait a minute. Wait a minute. We can use trigonometric substitution. But look at this. Look at this. You see this x squared plus 4? What's the derivative of x squared plus 4? X. Oh, that's in the numerator. I'm just missing the 2. Look at this. Let u equal x squared plus 4. du is equal to 2x dx. See, there's my x dx. I'm just missing the 2. So I multiply by 2, multiply by a half. And so this is going to be 1/2 integral. Well, what's 2x dx? 2x dx is du. And then I put the u in place of x squared plus 4. So that's u to the 1/2. And so that's 1/2 integral u to the negative 1/2 du. So that's going to be 1/2 times, add 1 to the exponent, multiply by the reciprocal of that, plus c. And so this is going to be what? Well, in the place of u, I'm going to put x squared plus 4. All right. And so that's just the square root of x squared plus 4 plus c. All right, so what in the world, what was the purpose for that problem? Well, the purpose for that problem was to show you, just because you see this, don't automatically go to trig substitution. So what I want to point out here, trig substitution, make that a last resort. See if you can do just regular substitution. See if you can do U-Substitution. See if that works. If it doesn't, then do the trig substitution. Well, in this problem, just regular U-substitution worked. Yes, I could have done trig substitution and gotten the right answer. But why do all that when I could just do this? All right, so be careful with that, okay? Be careful with that. All right, so let's look at this one. All right, so we've got dx over x squared minus a squared. All right, so if you look at that table at the very beginning, what's x going to be? All right, so x is going to be a secant theta. And so dx is what? Well, what's the derivative of secant? Why did I put d theta? Dx is a secant theta tangent theta d theta. All right. So let's make our substitutions. So that's going to be dx over, and in the place of x, I'm putting a secant theta. So a secant theta squared minus a squared times dx. Well, let's take the dx off. I don't know why I put it there, but in the place of dx, we're going to put this a secant theta tangent theta d theta. And we need to put that underneath the square root. All right, so we've got a secant theta tangent theta over the square root of a squared secant squared theta minus a squared d theta. All right. So this is the integral a secant theta tangent theta over, now I'm going to factor out a squared, and that leaves me with secant squared minus 1. Remember, 1 plus tangent squared is secant squared. You see that? Well, what is this? Tangent squared is equal to secant squared minus 1, right? See, factor out the a squared. I'm left with secant squared minus 1. Secant squared minus 1 is tangent squared d theta. And so that's the integral a secant theta tangent theta over a, and yes, absolute value of tangent theta, but it's positive, so I can just write down tangent theta. And so this is going to give me the integral of secant theta d theta. All right, so that's nice. Let's see what we have here. What's the antiderivative of secant theta? Well, remember, that's natural log absolute value secant theta plus tangent theta plus c. That's one of your formulas in your trig table that you learned back in chapter 5. Chapter 5 in most books, when you first learned how to integrate. So we need to know what secant theta, tangent theta, we got to get all that in terms of x. So we're going to make a triangle. All right, what was my substitution? X equal a secant theta. X equal a secant theta. So secant theta is equal to x over a. And if I call this theta, all right, well, remember, cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So that's x and a. And then by the Pythagorean Theorem, this is the square root of x squared minus a squared. Okay. All right, so now let's see what we've got here. Well, the first one, that's easy. Secant theta, we already got that. That's x over a. Now we need tangent theta. Well, tangent is opposite over adjacent. So that's square root of x squared minus a squared over a. So now we just replace everything. So that's natural log, absolute value. Secant theta is x over a plus tangent theta is square root of x squared minus a squared over a plus c. And there's your answer. All right. So you can see these aren't too bad. Just remember, to get it back in terms of x, you need to draw your right triangle down here. And then just see what you've got and, plug it in. All right. So how about this one? All right, so this one kind of looks like a nasty one here. And it don't really seem to match what we've had. Everything was square roots, right? So let's write this 0 to 3 square root of 3 over 2 x cubed over, and that's going to be the square root of 4x squared plus 9 cubed. All right. Now, how about this one? All right, so, I don't know. This right here, this 4x squared, normally it's just x squared there. It's x squared there, and we would let x equal whatever. And this, if we had x squared plus 9, that would be x equals 3 tangent theta. But we got a 4x squared. Well, couldn't we look at 4x squared as 2x, all of that squared? So maybe we could say 2x is equal to what? 3 tangent theta. So I get 2 dx is equal to 3 secant squared theta d theta. So dx is 3 halves, right? 3 halves secant squared theta d theta. You see that? So now let's plug everything in. So this is going to give me, and I'm going to leave a little more, I'm going to leave a little room here. And so we plug what in? X. Well, we've got 2x. Well, what's x? X is equal to 3 halves tangent theta, right, if we solve for x. So this is going to be 3 halves tangent theta cubed over, now remember, this 4x squared, I'm looking at that as 2x squared. So 2x is 3 tangent theta, so 3 tangent theta, but remember, that is squared. You see that? Plus 9, and that's the square root, and it's cubed. All right, it's cubed. And then times what? Times dx. And I forgot to put my dx there. Times dx. So in the place of dx, I'm going to put 3 halves secant squared theta d theta. All right, so let's see what we've got here. Oh, and the other thing we forgot to do is we do have to change our limits. You see that? We do have to change our limits from x to theta. All right. So we have this 2x equals 3 tangent theta. So we've got let's change our limits. We've got 2 times x, which is 3 square root of 3 over 2, equals 3 tangent theta, which this gives me, let's see, the 2's cancel, and then if I divide by 3, I'm left with tangent theta equals square root of 3. All right, and so this tells me that theta is equal to pi over 3. Remember, the inverse tangent of square root of 3 is 60 degrees, which is just pi over 3. And then, so this is going to be pi over 3. And then I got to plug the 0 in for x right here. And so I have 2 times 0 equals 3 tangent theta. So that tells me tangent theta is equal to 0, because that's 0 divided by 3, 0. And so that tells me theta is equal to 0. All right, so let's see what we've got. We've got 0 to pi over 3, and that's going to be, what, 27 over 8? 27 over 8 tangent cubed theta times 3/2 secant squared theta over, and then of course the d theta out here, and then that's over 9 tangent theta, or tangent squared theta, plus 9, and that's the square root and all of that cubed. All right, so let's simplify this a little bit. So that's going to be 0 to pi. Okay. If I multiply this up here in the numerator, that's going to be 81 over 16 tangent cubed theta secant squared theta over, now I'm going to factor out a 9, so that's going to give me the square root of 9 times what? Well, factoring out a 9, that's tangent squared plus 1 left over. What's tangent squared plus 1? That's secant squared d theta. All right. And so now, what do we have? Oh, and that's pi over 3. And so we got 0 to pi over 3 of, what is that? 81 over 16 tangent cubed theta secant squared theta over 3 secant theta. And remember, all of that is cubed. All right, so this is going to be 0 to pi over 3, 81 over 16, tangent cubed theta, secant squared theta, over 27 secant cubed theta d theta, because I got to cube that. All right. And so now we're going to have 3 over 16, 0 to pi over 3. Now, where did that 3 over 16 come from? Well, look at this. 81 over 16 over 27 over 1 is equal to 81 over 16 times the reciprocal. And there's my 3/16, and I just pulled it outside the integral. And then, let's see, secant cubed and secant cancel. So I'm going to be left with tangent cubed theta over secant theta d theta. See, the cubed and the squared cancel. I'm left with the secant to the first power. All right. So now what we want to do is let's rewrite everything in terms of sine and cosine to try and integrate this thing. And so this is going to be 3 over 16, 0 to pi over 3, and that's going to be sine cubed theta over cosine cubed theta over 1 over cosine theta d theta. And so this is 3 over 16, 0 to pi over 3, sine cubed theta over cosine cubed theta times the reciprocal of this times cosine theta over 1 d theta. And the cosine cancels, and I'm left with a squared there. So that is 3/16, 0 to pi over 3 of, what is that? Sine cubed theta over cosine squared theta d theta. Okay, so now what do we do? Well, this is going to be 3/16, 0 to pi over 3. Yeah, I thought this would be a nasty one, and it is. So we got an odd power of sine, so I'm going to save a factor of sine. So that's going to give me sine squared theta times sine theta over cosine squared theta d theta. And look at this. Sine squared is what? 1 minus cosine squared over cosine squared theta. And I'm going to just write the sine theta out here just for fun. Because look, what's the derivative of cosine? Derivative of cosine is negative sine. There's my negative sign. I can use U-Substitution now. I just need a negative. And so what do we have here? I'm going to let U equal cosine theta. So du is negative sine theta d theta. See, I need a -1 right here. So if I multiply by -1, I have to come out here and multiply by -1. So this is going to give me -3 over 16 integral, and that's going to be 1 minus u squared over u squared times negative sine theta d theta. Well, negative sine theta d theta is du. All right, but what do I have to do now? All right, I've already changed my limits once, right? I've changed my limits once. So I've got to change them again because I changed my variable to u. Well, what's u? U is cosine theta. So u is equal to cosine of 0. I'm going to plug the 0 in for theta. And what's the cosine of 0? That's 1. All right. And then u is equal to cosine of pi over 3. I'm going to plug the pi over 3 in. And what's the cosine of pi over 3? Pi over 3 is 60 degrees, and that is 1/2. And so that's 1 to 1/2. All right, so now let's see what we've got. We've got -3 over 16, 1 to 1/2, and I'm going to split this up. This is 1 over u squared minus 1 du. See, that's 1 over u squared minus u squared over u squared. U squared over u squared is 1. And so this is going to be -3 over 16 integral 1 to 1/2 u to the negative 2 minus 1 du. And so this is going to give me negative 3 over 16. And that's going to be what? That's u to the negative 1, and then times negative 1 out here. Multiply by the reciprocal of the new exponent minus u, and that's from 1 to 1/2. And so this is negative 3 over 16 times negative 1 over u minus u from 1 to 1/2. And so this is going to give me negative 3 over 16 times negative 1 over 1/2 minus 1/2 minus negative 1 over 1 minus 1. And when you figure all that up, you end up with 3 over 32. And that's your answer. Yeah, that wasn't a very fun problem, was it? But we got through it. We got through it just fine. All right, let's see. Do we have any more problems to work? Yes. And this is the last one. Okay. All right. So this one looks kind of weird. It doesn't match any of the properties we have in the table. So let's see if we can make it look like that. Okay. All right. So we're gonna have to rewrite this denominator. So that's gonna be x over the square root of 3 minus. Now what I did is I factored out a negative on these two terms here. So that's gonna make it positive x squared and positive 2x dx. All right. And then what I'm going to do is I'm going to complete the square right here. Okay. And so this is going to give me the integral x over the square root of 3 minus, and that's going to be x squared plus 2x, and leave a little space. Okay, so I half the 2 and square it, so half of 2 is 1, 1 squared is 1. And then since I added 1, I have to subtract 1. But notice adding 1, notice this negative in front. If I distribute that negative, it's like it's minus 1. So that means I got to come out here plus 1. And let's not forget the dx. And so this is going to give me x over 3 plus 1 is 4. And then this is a perfect square trinomial, so that's minus x plus 1 squared dx. All right, so still it doesn't quite look like it's supposed to. I mean, if it was 4 minus x squared, that would be nice. But what I can do here is I can use U-Substitution right here. So I'm going to let u equal x plus 1. So du is equal to dx. So the x plus 1, I can replace that with u. The dx, I can replace that with du. But what about this x? What is x? Well, x is u minus 1. See, if I solve this for x, I get u minus 1. So the x I can replace with u minus 1. And so now that is going to give me u minus 1 over the square root of 4 minus u squared du. So I'm in terms of u now. All right. So now this looks like what? What am I going to make my substitution? Well, I'm in terms of u, so I'm going to let u equal a sine theta. And in this problem, a is 2. 2 squared is 4. So that's 2 sine theta. So that means du is 2 cosine theta d theta. All right. So now let's make all of our substitutions and see what happens. All right. And so this is going to be what? 2 sine theta minus 1. I just replaced this u with 2 sine theta over 4 minus 2 sine theta squared du. I'm sorry. I don't know why I wrote du. What's du? That is 2 cosine theta d theta. You got to make your substitutions. All right, so we have, let me put the square root there. So we have the integral 2 sine theta minus 1. And let's go ahead and do this. So times 2 cosine theta over the square root of 4 minus 4 sine squared theta d theta. Okay, I just put this 2 cosine theta up here in the numerator. And so that's going to be the integral of 2 sine theta minus 1 times 2 cosine theta over, now remember, I factor out the 4, and that's 1 minus sine squared. What's 1 minus sine squared? That's cosine squared d theta. And so this is going to be the integral of 2 sine theta minus 1 times 2 cosine theta over 2 cosine theta d theta. And so what does this give me? Well, look at that. The 2's cancel, the cosines cancel, and I'm left with 2 sine theta minus 1 times d theta and this is going to give me, well, what's the antiderivative of sine? Negative cosine. So that's negative 2 cosine theta minus what? Minus theta plus c. All right. So don't forget, our problem is in terms of x. So I've got to get everything back in terms of x. Well, this is my substitution. U equals 2 sine theta. So let's draw our triangle. U equals 2 sine theta, not x, u. And so sine theta is u over 2. So if this is theta, then remember sine is opposite over hypotenuse. So opposite over hypotenuse, and using Pythagorean Theorem, I get 4 minus u squared right there. So I need to know what cosine theta is. Well, cosine theta is equal to adjacent over hypotenuse, So that's the square root of 4 minus u squared over 2. And then what's theta? Well, theta is equal to the inverse sine of u over 2. All right. So I get this to be what? Negative 2 times the square root of 4 minus u squared over 2 minus theta, which is inverse sine of u over 2 plus c. But remember, we've got to get everything in terms of x. Well, what is u? Let's come back up here and look. u is x plus 1. So I'm going to replace u with x plus 1. And so this is going to give me, well, the 2's cancel, right? The 2's cancel. So that's going to give me negative square root of 4 minus x plus 1 squared minus the inverse sine of x plus 1 over 2 plus c. Let me erase this. And so this is going to be negative square root of 4 minus, and then x plus 1 squared is x squared plus 2x plus 1. All right, because remember, x plus 1 squared is x plus 1 times x plus 1 minus inverse sine of x plus 1 over 2 plus c. And so that's negative square root, and that's going to be 4 minus 1, which is 3, minus 2x minus x squared minus inverse sine x plus 1 over 2 plus c. And this is our answer. All right, and guess what? That is the end of the video. So, yeah, these problems are nasty. That's just all there is to it. It's a lot of substitution and switching things out and all that mess. But, you know, that's what you got to do to work them. So, I hope this video helped. Check out my other videos. And look, if you made it to the end of this video, let me know in the comments. I'd be interested in that. So if you like the video, give me a like, share, and subscribe. Thanks for watching, and I'll see you